Okay, hi guys. Welcome back. Uh, this is week 8 for our coding club, and we're nearing the end of it. And everyone's gotten so much better at coding from the beginning. So, so I was thinking that we could probably do a project today. And but before we finish do our project, I'm gonna start with going over the functions we went over last week. Uh. So just tell me in chat, was anyone able to finish was anyone able to figure out the Fibonacci function? To print the from week 7, there's a question to print out like the first n terms of Fibonacci. So yeah, so if anyone could figure that out, that's cool. Uh, so all right, so even though okay, so I'll go over that one real quick. Oh nice, so a lot of people did figure out. That's great. So since a lot of you guys did figure out, so I'll go over it really quickly so I don't take up too much of your project time. And I'll first start by talking about what I wrote. So basically, what we have here is we want to write a Python program to solve the Fibonacci sequence using recursion. And the note is that you have to remember F1 is 1, F2 is 1, and well, actually, no, F1 should be 0, actually. F2 is 1, um, F1 is 1, and then I'm going to define F of 0 is also is 0. So the technically Fibonacci starts from 0 at 1, 1, and then 2, 3, all the way on. So the way I thought of it was the easiest way I thought was to define two different functions. So instead of just doing everything in one function, I made a function that returns the nth term of a Fibonacci sequence. And how I did that was uh, you define a function recur Fibonacci n, and this number n is just the nth term. And basically, if n is less than or equal to 1, which means that if it's 0 or 1, then um, it'll basically return its value. So like as you see here, f of 0 is 0, so that matches 0, 0. F of 1 is also 1. So that covers both of those cases. And if if it's f of 2 or anything greater, then what it'll do is it'll go to this else statement, and then it'll return the function, like it'll use recursion and return the function of itself of n minus 1 plus n minus 2. So let's say the function was f of 2, then f of 2 would return f of 1 plus f of 0, and both of those meet this condition, so it'll just return 1 plus 0, which is 1. F of 3 would return f of 2 plus f of 1. F of 2 would return f of 1 plus f of 0, so it would return 1 plus 1 plus 0. No, 1 plus 1 plus 1 plus 1 plus 1, which would return 3. So basically, yeah, so every single time that for n is still greater than or equal to 1, it'll just keep on recurring to the sum of the two numbers lower than it. And that's how you get the nth term. And basically, we have created another function, the big function Fibonacci, and then we have a parameter n terms. And so we have to first check that the number of terms to enter is greater than greater than 0. So it can't, if it's less than or equal to 0, then you're basically not putting out anything. So if it is, we just ask them to please enter a positive integer. And otherwise, we will print the Fibonacci sequence. So, and we use a for loop to iterate through every single value. So for I in range of n terms, then we will print recur Fibonacci of I. And it's basically I becomes like starts with 0, this starts with 1, starts with 2, and it'll print whichever Fibonacci value it is. So if I run this, when I is 1, it'll just return. Sorry, when I is 0, returns this. When I is 1, it returns this. When our I is 2, it returns 1. I is 3, it returns 2. I is 4, it returns 3, all the way up until I is 10. And then, sorry, this should be I is 9, and I is 9 returns 34 because of this function. So that's basically how I did the recursion Fibonacci sequence. And I'm sure there's a lot of other ways to do it using I'm sure there's a lot of other ways to do it with recursion. You can also probably do it with the for loop maybe. That's probably a lot harder though. So hopefully everyone understands this, and if so, we'll just move on to the Hangman project. And this I'm gonna leave mostly up to you guys. If you do have any questions along the way, you guys can ask me. Hangman's a really good beginner project that most people doing Python have probably gone through, or any coding in general. And and I'm sure all of you guys have played the game Hangman. And the idea of the game is that whenever you have a certain number of tries and it's a random word, and you'll keep on guessing letters until you either get the word or you run out of tries. And hopefully all of you guys have played the game Hangman. If not, I can explain to you guys how it works again. But we're gonna do a simulation of that in Python. So to get you guys started, I'll write like the first couple lines of code for Hangman. And so what we want to do with Hangman is we first want to get a large list, a single word from a very large list of English words. And how we do that is, also I should probably share to you guys the link. Yeah, my bad. So anyone with the link can get it, and then copy the link. I'll send it to everyone. Okay. So use this. You guys use this to program the Hangman project. So to start, there's this website that I found on Stack Overflow. It's just a JSON file with a very large list of words, and I'll paste that in the chat as well. So here we go. So what we're gonna do with this is if you click on it, you'll see something that looks like this. And it's just I think it's like 5,000 English words. That should be plenty. And what we're gonna do is we want to make a list of these words, and we want to just like randomly choose a letter from this. Let's go back here, and then we'll define a list words is equal to this large list, okay? And then don't scroll left. It basically takes up 3 lines because it's so long and it scrolls all the way to the right, and that'll just be sitting at the front of our code. So hopefully everyone's done this. Is everyone okay with going to the website and grabbing that list? So did everyone do that? Okay, cool. That's great. So once you've grabbed this list of words, what we want to do is we want to define a function before Hangman. We want to actually get a random word from this list. And I don't think I've actually so what we can do is we can define a function called get word, and this will take in we can take in one parameter. We don't have to take in any parameters. It's probably easier that way. And then what we're gonna do is we want to have word is equal to, we want to actually just return words dot random. And it's okay. We'll have word is equal to words dot random. So we want to get a random letter, and how we do that is random dot choice. And this function dot choice basically takes in a very long list and chooses a random element from that. So if we plug in words here, so we just need to do random dot choice of words, which is a list. And if you notice here that I use this random library. So if we want to use random, we have to first import random, which is a Python library that does a lot of things with random stuff. So make sure you have import random before you use the random library, or else it'll just tell you that it can't find the library random that you're trying to use. And the problem with we have right now is that a lot of words in this thing have in our large list have like colons or spaces. If I can find a word that looks like that. So anyways, I believe some of the words here have colons, sorry, like have these. I don't know if these are called like just dashes, I think. Yeah, they have like dashes in them, and we don't want that. So we're gonna use a while loop to keep on getting words until we get a word that doesn't have a dash or doesn't have a space. So once we do choose a word here, we'll do while. We'll check if while a dash is in word or a space is in word. We will keep on looking for a new word. Then, and then whenever we find a word that doesn't have a dash or space, we'll just return word. And that's what our get word function will do. So now that we're done with getting words, we're gonna set up some of the stuff for Hangman. So firstly, we want to have a local variable word that's equal to get word, and this is basically the word that we're going to be trying to guess, and that's why I name it word. And also we want to have an alphabet variable, since whenever the user is guessing a word, we want to make sure that it's inside of the alphabet and it's not like some random, and it's not like a dash key or parentheses or star or anything like that, because that won't be inside of this word list. So there's actually we can import a library string that has a lot of useful like lists and stuff that we can do. So alphabet is equal to, if we make a list of if you type this exact thing in ASC II and then lowercase, this will return this will basically return a list of alphabet, the alphabet that's in lowercase. If we print alphabet, then we'll get to see that. Yeah, so as you see, alphabet here is a list of the lowercase letters in the alphabet. And by the way, the reason why we make it lowercase is because we're going to be doing our entire Hangman by using lowercase letters. So even if the user inputs an uppercase letter, we'll turn that into a lowercase letters, since we learned that in Python an uppercase A is different from a lowercase a. And we can remove this print alphabet for now, since we don't need it. And so now we have the word, we have the alphabet we could compare it to. What we want to do is we basically want to get some sort of user input. And so actually from here on, I think this is all the stuff that we didn't learn yet. So from here on out, I think I would leave it up to you guys. So we have an alphabet. We have a function that gets a word from this large list of English words. And oops, what did I do? Okay. Um, everything's okay, right? I think it's okay. Um, so we have the alphabet, we have a function that gets a random word. And now uh the rest, I think you guys can try to figure out. What we're gonna try to do is essentially it'll look like this. You'll have a how to explain this. So if your word is like 10 letters long, it's like apple. Sorry, if your word is like 6 letters long, like apple, 1, 2, 3, 4, wait, no, 5 letters long. Apple's 5 letters long. So if your word's apple, then first it'll look like that. And let's say the user guesses A, it'll be A, 1, 2, 3, 4. And empty letters will be represented, like not guess letters will be represented by dashes. Guess letters will be represented by the actual letters itself. And then let's say they guess P, A, P, P, L, E, sorry, A, P, P. And then if they guess L, it'll look like this. And eventually it'll be like A, P, P, L, E. And then they win the game. So if any of you guys need help on how to start this or have any questions along the way, feel free to ask me, but I'll leave the rest of like the 40 minutes to you guys to try to figure this out. Um, I think I think I'll make this like a 2-day project. So don't worry if you guys aren't finished by the end of this class, since this is a pretty, this might be a pretty difficult project for a lot of you guys. But I don't want to waste any of your time. So um, you guys can go ahead and try this on your own. And also if you guys have any questions, make sure you ask me and I can guide you along the right direction. There's many ways to do this, so your solution might be a little bit different than mine. But as long as they, all get the job done, then it's cool.
Andrew.
Oh yeah, what's up?
Oh yeah, so the thing is that my gaming project will not work if a word has two of the same letters.
Oh yeah, so um if you don't mind, if you don't mind, if you could screen share your code, I can probably help you debug that. But there's a way to get if your if your word has two of the same letters. So
Yeah. So here's oh yeah, so
oh, I
here's
should
my
stop sharing. Okay.
so anyways, here's my code.
Okay. Um.
So that will work because that has two E's. See, so when I do B and then I do E and I keep on doing E's, it won't show up as progress.
Um.
So
That's lowercase. Okay. First of all, I see that you're printing the whole string every single time. So like you're printing believe every single time. So like do you know what the point of that is? Oh, are you just printing solution for like your own purposes that way?
yeah, so that
Okay.
I will know what the code is doing better.
Okay, I see. So let's see. So solution, if letter is in solution, then progress of solution dot index is equal to letter. So if you notice this, right, what you're doing is you're only checking if letter is in solution once, right? So a way to get around that is if you can like if you can find a way to iterate through every single item in the solution and then replace every single E at once, because that's how Hangman works, right? How would you do that? Like is there a way you can think of?
I could use a for loop and loop it, checking each one, like if progress I is equal to solution I
Mm-hmm.
equal to letter I mean. Solution.
Mm-hmm.
Yeah, so I could loop it.
Okay. So you can try creating a loop. Uh this one.
So I'm just going to do length of progress if let progress solution I is equal to letter then progress I is equal to letter. Yep. So that's my loop.
Okay, let me read it. So for I in range, length of progress, um, if solution of I is equal to the letter, okay, um, then progress of I is equal to letter. Um, I mean that looks like it'll work.
Okay,
You can try it.
I'll try it. Oh yeah. How's this? Wait a minute. It isn't picking up the A. If I do A again, then it's not going to work.
Let me check. So okay, it's assorted. Your current progress is shown here. Um, solution. Okay, so the problem is that none of them are getting replaced right now, which
Yeah.
means that that probably means that it's not finding letter in the solution, which is um an if solution. Let me see for I in range.
A.
Print the frog. Oh, a solution is equal to letter. Hey, that's weird. Let me uh if okay, so solution you have as a list, right? And then progress you also have as a list, and then so while tries is not equal to 0, then you'll find a new one, and then you check that if the letter is in the solution, then so while the letter is in the solution, then for I in range, length of progress.
So do you think you know what's going wrong?
Um, I'm not completely sure either. Because that I don't know, from what I see, that looks like it should work, but okay, okay, try printing something in like inside of your for like okay,
Print
just like print anything or just
I.
that works.
Oh, that's not a two-letter word. Oh yeah, it has two I's. I.
Okay, so it does iterate through every single one of them, which means and then okay, it iterates through every single one of them, but the problem is that it does not oh I see. So the problem is it doesn't replace it. Oh, progress I is not double equal to letter. It should be equal to a single equal to.
Oh, that's a big oof. Let me try again. Nope, that's not a double-letter word.
Mhm.
Oh, that does it.
There we
Thanks.
go. See, yeah, no problem. All right, wait, I think you're pretty much done, right, Eric? That's
Yeah.
yeah, okay. Sounds that's a great job. Okay, so class is almost over. So I'll just do like a let me see if I can get just a quick poll of whether or not you guys are done or not. Uh, So okay, just yeah, just if you guys could just please just type it to me in chat if you guys are done or not. So I'm probably not gonna give you guys my solution to this yet. Because I really want you guys to work on this yourself, and you know, if it's just like a sense of accomplishment if you guys figure it out without me giving it to you guys. Um, so yeah, if you guys did finish, please just quickly type it to me in chat. I would really appreciate to know like the progress you guys have made so far. Okay, so we're like half done, half not done, it seems. Um, okay, it looks like we're half done, half not done. So next class will start by um next class we will start by finishing this up. I'll give you like the first half of class to finish it up. Um, for those of you who already finished, I do have another project lined up for you guys to try. And for those of you who haven't, I'll give you guys time to work on it during the next class. And once everyone's done, I will show you guys my solution. So anyways, thank you guys for all coming. Today was a pretty fun class. Glad to see that you guys all have gotten very good at programming and made a lot of progress. So anyways, see you guys next week and bye bye.
Okay.
Thanks. Bye.
See you later.
Okay, now it's just totally me again. So I think I'm almost finished.
Okay, that's great. I mean, if you like I said, I'll give you guys time during next class to finish it. So oh, cool, okay.
Yeah, I'm just using a copy of your stuff.
Hmm.
So what I did is that first I tried to use worded dot replace, but of course I can't do that because I don't know what letter I need to replace it. Like I don't know if the letter there is a B or a C or whatever. And then I had this tracker thingy, and I'm pretty sure it's the same as the progress thingy that you were looking with Eric's.
Hmm. So if wait, so do you need help on this? Is that what you're saying? Okay, so instead of doing dot replace, what you can do is I think someone else ran into this problem as well. So you're first checking. So while this is in tracker, okay. So if inputter in alphabet and inputter in word list, um, that looks correct. And then tracker. So then, like we did with your brother, right? You can use a.
That's not my brother.
Oh, that wasn't your brother. Oh,
Yeah.
yo, sorry, I'm the wrong guy. So you can use a for loop, right? To loop through every letter in worded, and then not using dot replace, but there's a way to use string concatenation to like mimic replacing a specific index.
But so like before I was going into some weird stuff where I had this stinky and like I thought that and for some reason I was thinking very weirdly and I thought that well, isn't it just easier to use dot replace on the tracker thing? Well, there's probably gonna be 5 different underscores there, so
Let me see. So dot replace, yeah, so dot replace does work, but the problem is that let me see, dot replace. Oh, wait, so dot replace replaces every, oh, it does. Okay, so dot replace replaces every old value with the new value. Okay, I see. Yeah, I just read that as well. So if you do, so you could do dot or dot replace, yeah. Wait a minute. Sorry, I'm trying to read your code right now. To inputter, okay, so if inputter, okay, num keeper. Sorry, what's numkeeper doing? What does numkeeper do?
so I was trying to replace the wait. Let me do something. Oh yeah, what equals list worded. So now keeper was supposed to like keep all of the numbers. Let's say that I have a word called EEAEER,
Mhm.
and I type in an E, then the non replace was supposed to keep in the 1, 2, 4, and a 5, so that will replace the thing. So that will replace the tracker at 1, 2, 4, and 5.
Okay, well then, oh, you're right. So that's the problem. That's why you can't use dot replace, right? Because you don't know where to replace it, right?
Yeah.
So to get around that, what I did is instead of using dot replace, you have to find the index at which this letter occurs. So you have to compare the index of the letter that they guessed to the index that it's in the word, and then basically replace that index with whatever user input that they put in.
And what so they want a string at it, and if you try to do something like string the list, let's say um REREAD, then would it print or read, or would it do something else?
Sorry, what's your question again?
So if I were to print this, then what would it print?
If that was the word list, you're saying.
So let's say that I try to print this thingy, then what would it say down here?
Oh, it would just if you just did print that, right? That's it.
Yeah.
Then it would print exactly what's inside. It would print the list, like with the brackets and everything.
Oh,
And you can try it right now, just like outside of Hangman. You can copy and paste that and then print it. It'll basically just print every str turns everything inside of it into a string, essentially. So like every bracket's a string. It's equivalent of putting parentheses around something, pretty much. Yeah, see, it'll just print everything along with the brackets.
So it seems like that I will have to use the for loop again.
I think you're gonna have to I don't think dot replace is the best way to do this. I think you're gonna have to use a for loop to iterate through word it and then check if it's equal every single time, and then if it is equal, then replace your tracker word. I think I think that should be a good hint to get you in the right direction.
Mm.
Okay.
Like
So sorry, if you want to work on this out like during between our classes, that's it's cool. But I'll also give you guys like 30 minutes in the next class to do it.
and like I don't really work very well with the indexes and strings.
Oh, that's all right. If you do have time, you can try to work on this like between things. I can give you, do you want me to give you a hint as how to replace a specific index letter?
Okay? Like with
So
this on a string.
yeah, so like given a string, you can, since you can't, since a string's not a list, you can't directly assign the string index value to be something, then there's a way to use string concatenation. Actually, I think I'll let you figure that out on your own. I think it's good practice for you to um, try to figure out how to replace a specific index in a string.
Well, right now my idea is to just turn the string into a list and
A
then
list?
change the index of the list and then iterate through and change it back to the string.
Um, that does work. You could try that. No, I think I could. I think that works. You can try that. So yeah, like I said, there's multiple paths to the solution. So if that's how you think of it, it's great. Anyways, I gotta go now. So see you next week, Nathan. A lot of fun
Okay.
talking to you.